Hello, and welcome. I'm currently in the process of making a new video for you. This time, it's going to be a fascinating alpha-type Stirling engine with a hot and a cold cylinder. And if you like, you can help me with this. How? Well, it's easy. I will have two questions, and if you like, you can leave a comment below this video as a reply to those. Thank you very much in advance. But what is this video going to be about? I'm trying to show a Stirling engine how it works by taking different measurements live while it's running. One of them will be most certainly the temperature of the cold and of the hot cylinder, but also the RPM. And if you have an idea what other measurements I should also take, please leave that in the comments. Additionally, I'm also interested in experiments that show the working principle of the Stirling engine. And my second question is about something that I discovered while doing the early tests for this video. It's a little bit of a weird behavior. If you have an idea or an explanation why that happens, please leave a comment below. So what's the issue? Now, I would have expected that the RPM, which I take as a performance measure of the engine, so the rotations per minute of the shaft, would actually increase with the delta T, the delta in the temperature. And that is the delta between the hot and the cool cylinder. So at first, at room temperature, when you first fire up the engine, the performance would be actually best. So the RPM would be very high, and over time, because of heat dissipation, the difference in temperature between hot and cool cylinder actually decreases. So I would have expected that the RPM decreases proportionally to that. Now, to measure this, I set up this experiment with a thermal camera and an RPM meter. So the thermal camera ranges from -20 to 350 degrees centigrade. And I know that's not quite enough to measure the heat of a flame, which is much warmer than that. But it's enough to measure the cold cylinder's temperature. And that's the important here. I was expecting that if you increase the delta T, so the temperature difference between the hot cylinder and the cold cylinder, that means that the performance would increase. So we have an increase in the RPM, in the rotations per minute. So meaning if you heat up the hot cylinder and through heat dissipation, the cold cylinder will also increase in temperature over time, basically starting from room temperature or where it was stored, the delta T will decrease. So meaning the RPM over time, over running it, should also decrease. Well, it's quite a bit more complicated what actually happened in this experiment. And if you have an idea which processes or which physical principles are behind this, I would greatly appreciate if you could comment in the comment section below. Now, what do we actually observe? At around 20 centigrade, it starts with 1550 RPM. And the cold cylinder is heating up to 30 centigrade, meaning the delta T actually drops, but the RPM increases to 1650. And from that point, all the way down to, so from the 30 degrees centigrade all the way down to 50 degrees centigrade, meaning delta T is dropping again, we have actually the behavior that was projected, so it drops in RPM all the way down to 1400 at around 50 degrees centigrade. And from that point, which is surprising again, it goes up. So all the way to 55 degrees, we reach again something like 1550 RPM. And from that point, heating the cold cylinder further up, meaning delta T further dropping, it goes again down to 1450 roughly. So yeah, that's a very interesting behavior. And if you have an explanation for this, please leave a comment in the comment section below. Thank you very much for watching this video and see you next time.